So I'll maybe do one question to kick us off, and then we'll maybe see if there's any questions from the audience. But we'll start off with the question, and by the way, thanks guys for coming up. Is it possible and reasonable to have a single vSwitch that supports both enterprise and network use cases?
Definitely. So as we can see that traditional enterprise workload and the workload has very different characteristic, but from networking switching perspective, essentially it's not a conflict. We can. So let's say the technology boost NF workload performance can really also benefit some sort of the enterprise workload. So it's not contradict. So essentially, we definitely can, if we design it correctly, we definitely can have a single architecture to really support both of them.
Because I noticed in your preso that you were presenting a number of different workloads alongside each other on top of CloudNet Engine.
Yes.
So this has actually been a strong theme in FDIO VPP. I'm wearing my FDIO T-shirt as well today. In FDIO VPP, and I think Florin, is Florin in the room somewhere? Hey, Florin. Florin's going to talk about it tomorrow, which is the work that's being done in the VPP TCP host stack, and that's the idea. There is to be able to support both enterprise applications based on things like BSD sockets, API, but then also things like VNF concurrently side by side. So I think there's certainly, we're seeing a lot of evolution towards much more lightweight interfaces in virtual switching to support things like containers, but then also you still have your existing investment in your virtual switches. Okay, we still have your existing investment in your virtual switches. So those same switches that we optimized previously for things like network use cases are now being extended and made more scalable to support container use cases as well. And I think we've seen that in CloudNet Engine as well.
Yes.
Okay. So do we have any questions from the floor? Okay, I'll launch into another one. What is the biggest obstacle to the adoption of containers for network functions?
Sorry.
What is the biggest What is the biggest obstacle to the adoption of containers for network functions?
Maybe I thought it's a combination of PaaS and IaaS that is infrastructure as a service to combine with the platform as a service.
Yeah. I thought myself, in this kind of stuff that I was talking to before, I don't think about those as obstacles. I think about things like sharing CPU time, sharing I/O, and sharing memory as we have good ideas to fix those. I think the more problematic pieces is actually how do we talk to things like Kubernetes? How do we talk to the SDN layer? And how do we support both? How do we support both classic how do we support both things like classic network functions, but also enterprise kind of infra at the same time? I think there's a ton of work that needs to be done there. Yeah. Can physical NIC offloading help accelerate microservices?
Okay, definitely the hardware offloading can help on microservice, but on the other hand, I think I might have some different opinion from some vendors from SmartNIC. Definitely, let's see TSO or take some offloading. Just traditional offloading is very helpful for handling enterprise workload. On the other hand, as we see a trend that try to offloading the whole data path into the SmartNIC, and so it depends. So there have pros and cons in each direction, but I think there definitely need a trade-off. And so hardware means much higher speed, but less flexibility for sure. And as we can see that in terms of offloading, it's very complex, and you need to handle many things. And the other thing is, let's say for classification, from a virtual switching perspective, it might need a very, very complex C classification instead of a traditional, let's say, 5-tuple or any extended tuple classification. So if that's in hardware, that might not easily to be extended. Another concrete example is that when we're doing the extreme NFV workload testing, we found that looking up pretty much only consume a little over 10% of the overall CPU consumption. So is that worth to move those function inside virtually inside a physical NIC? That's debatable, I think. But I think generally that definitely it will be much more flexible in software. Okay.
Ray, we've got a couple of questions from the audience if you're open to taking a couple, Ray.
This is my first time running a panel discussion. Yes, that's a great idea.
Okay, great.
Could you comment a bit on how you see network security applied to containers? For example, if we're saying...
I can't quite hear that.
Can you comment on how you see network security applied to containers? For example,
Sure.
if you're giving away the queue pairs or virtual functions directly to the containers, then you'd have to have some way to secure that traffic. So it has some overlap with your cooperative sharing comment. How do you guys see security for networking in containers working?
Did you say the security of container networking? Yeah. Maybe we could separate the different containers to the access priority to different containers. Maybe one is they didn't have the totally priority to all the resources, and we can just give the maybe high priority to the programmer to the maybe DPDK container, and other application container has low priority to the resources.
So something else I think that you both referenced in your presentations is something that's not unusual is to run your containers inside a virtual machine. So by running your containers inside a virtual machine, if you do suffer a security breach, you still ultimately maintain a layer, a separation between the containers and the host, so you still can control the host. There is also, for instance, both Ronnie and Francois earlier talked about using separate device pair queues per container, so you're able to very, very deliberately slice the I/O to share between multiple containers. So there are definitely ways, securing behind an I/O MMU, etc., to make them more secure, definitely. And actually, I think there's an interesting project called Clear Containers that does exactly that, where you run a much more lightweight container inside a lightweight virtual machine, and it probably gives you the most security. So a little bit going back to my prezzo is that there needs to be a broad spectrum of options. For those people who are most security conscious, you might want to do something like a Clear Containers model, right? When you run the container inside a virtual machine. For something, let's say, if you're willing to compromise a little bit more, you might run all your containers inside one single virtual machine and maintain that separation. But then if you want something like perhaps something that's bare metal completely, well, we need to have options to support that as well.
And one more question from the audience.
Yeah. It is really often said that DPDK does not support containers. What do you think we should change to change this feeling?
I didn't get the question, okay?
So the question was, it was more of a comment that there's a perception that DPDK does not really adequately support containers. And so I think that the question was, how do we fight that perception? Did I get that right?
Okay. Well, I think it depends on what way you view containers. Well, okay. So today you can kind of change the shrink wrap. You can take something that's been deployed inside a virtual machine and you can put it inside a container and you're done. It really depends on how you kind of view the movement towards containers. Are people moving towards containers? Are they simply looking to change the shrink wrap, or are they looking for improved scalability, improved robustness, those kind of characteristics that typically come from the kind of applications that are typically deployed in containers. So at that point, is containers for a byword for a set of characteristics, or is it just simply changing the shrink wrap? So to my mind, it's a move towards a cloud set of characteristics that are typically, you typically see with applications that are deployed by things like Kubernetes. So in those models, in those applications, they are typically scalable. They typically run many on a single core. They typically have a lightweight memory footprint, and they typically share I/O. So it really depends on what way you view containers. Is containers a change of shrink wrap, or is it a move towards a cloud model? And you can view it either way. So in my Prezo, I was taking it as a more move towards a cloud model. But that's not to say that there aren't many who will view it as, say, actually, you know what, just changing the shrink wrap from VM to container is enough for me also.
All right, I think we better move on. We're about 12 minutes behind schedule now, so thank you very much.